go, guys. Here we go. Sigma notation. We're going to start out with sigma notation today. This is our last part of this unit of this section. 6.1. Sigma notation is actually pretty simple. It basically is a notation we use to signify that we're going to add up or sum up part of a sequence. So it comes, sigma is the Greek letter, and the way that we write it is we use a capital Greek letter. So there it is, the capital Greek letter sigma. There's a couple parts to it. We have the bottom part here where k equals 1. The bottom part here tells you where you begin. So you begin at the first term. The top number here, which in this case is n, is where you're going to end. You're going to end, in this case, at the nth term. And what you're going to do is you're going to add up all of the terms until you get to whatever that top says. Okay, so sigma, sometimes you'll see it on Excel. If you're trying to sum up a bunch of cells, then they have actually a shortcut button, and it's that sigma button. Let's go ahead and take a look and do a problem here, okay? So let's go ahead and take a look at slide number 26. It says find each sum. All right. Oh, by the way, I forgot to tell you what this part was. This is the explicit equation, which tells you how to find the numbers you're adding up. So the bottom number here, 1, tells you where you're beginning. You're beginning at the first term. So take 1 and plug it in for k. That's going to be 1 squared. Then you're going to go up by integers until you get to 5. So 1, 2, 3, 4, and 5. So we're going to take 2 squared and 3 squared, 4 squared, and 5 squared. Why did I stop at 5? Because that's where that said to stop, was at 5. Why did I start with a 1? Because that's where that said to do, was start with a 1. Why did I square them? Because that's what the explicit equation told me to do. Why am I adding them up? Because that's what sigma tells me to do. So sigma notation is pretty cool. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and I just add those up. 5 plus 9 is 14, plus 16 is 30, plus 25 is 55. So the answer to A is 55. Let's look at B. So for B, let's see what it tells us. It says we're going to start at 3, we're going to go to 5, and we're going to use 1 over j to find them, and we're going to add them up. So the first one should be 1 over 3. Why a 3? Because that's where it tells me to start. Plus, then I just go up by integers. 4, I plug in a 4. It's going to be 1 over 4 plus, and then go to 5, 1 over 5. Why did I stop at 5? Because that's what it said. Why did I start at 3? Because that's what it said. Why are there plus signs? Because that's what sigma said. How did I get 1 over 3? Because that's what 1 over j said. I'm just plugging in the numbers and adding them up. So 1 over 3 plus 1 over 4. Get common denominators between 3, 4, and 5. Well, you can start out with 3 and 4. Common denominator is 12. So this is going to be times by 4 to get to 12. Times by 3. So you get 4 plus 3, which is 7, over 12 plus 1 over 5. Common denominator between 12 and 5 is going to be 60. So multiply this by 5. Multiply this by 12. 35 plus 12 is 47. And the answer to that is 47 over 60. And you're done. Okay? Let's look at D. Oh, look at C, I mean. We're on C. Hello. We're on C. So let's look at C. C says we have k equals 5 up to 10. So we're going to start at 5, go up to 10 for k. So the first one's going to be 5. How come? Because I took 5 and plugged it in. How come I started at 5? Because that's what the bottom said to do. Plus. Why a plus? Because that's what sigma says to do. Now the next number is going to be 6. Then 7. Then 8. Then 9. Then 10. Why did I stop at 10? Because that's what the 10 told me to do. How did I know I went 5, 6, 7, 8, 9, 10? Because k says it's just k. So you go by integers all the way up from the bottom number to the top, going by integers. 5, 6, 7, 8, 9, 10. Always integers. Always integers. Okay, 5 plus 6 is 11. 11 plus 7 is 18. 18 plus 8 is 26. 26 plus 9, 35 plus 10 is 45. C is 45. Let's look at D. Okay, so D says we're going to start with I equaling 1, going up to 6, and the answer is 2. So we have 2 plus 2 plus 2. It doesn't matter what you plug in. Since it's just a constant of 2, you're always going to have 2. 2, so this is the first term, second, third, fourth, fifth, and sixth. How do I know I stop at the sixth term? Because that's what that says right there. How do I know I start at the first term? Because that's what it says right there. How come this is a 2? Because that's what it says right there. Why are we adding them up? Because that's what sigma says to do. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, 10, 12. The answer is 12. All right, that's sigma notation. Let's now go ahead to slide number 28. I'm going to try again. This time we're going to go backwards, okay? We're going to go a little backwards now. So in other words, we're going to write this in sigma notation. I'm going to write this in sigma notation. So I notice that I'm adding these up every time, so I write sigma. Okay? Now, I'm going to call this my first term. So I'm going to say n equals 1. That means this would be my second, third, fourth, and fifth. So I'm going to go up to 5. So 1 up to 5. Now the question is, how can I get out? So what's happening? We need to ask ourselves what's happening between each of these equations every time. So we need to write it. So from 4 to 8, you could say, okay, I add 4. From 8 to 12, I added 4. So I add 4, I added 4, I add 4, and I add 4. So every time I'm adding 4. So if you repetitively add 4, repetitive addition is multiplication. So that's going to be 4 times n. Because I'm repetitively adding by 4. So 4 times n. Now if I plug in a 1, let's see if I get out the right number. 4 times 1 is 4. Got it. 4 times 2 is 8. Got it. 4 times 3 is 12. Okay, so I have it. There it is. Sigma notation done. All right, let's see what happens here on B. So again, we're adding them up. So that tells me I'm going to use sigma notation. I'm going to start with the first term. I always just say this is the first, second, third. Now the question is, what term is 66? We got to figure that out. Well, there's a couple things we need to do first of all, too. Let's figure out the explicit equation. I'll show you how to get that 66, okay? So, for the explicit equation, what am I doing from 6 to 11? I'm adding 5. 11 to 16, adding 5. So every time I'm going to be adding 5. Repetitive addition is 5n. Now the deal is, if I plug in a 1, here I get 5 times 1, which is 5. But I don't want 5, I want 6. So how do I get that? I add 1 to that. So add 1. Let's see if that works for the second equation, or for the second term. 5 times 2 is 10, plus 1 is 11. 5 times 3 is 15, plus 1 is 16. There it is. So repetitive addition is multiplication. Then I just took the first term, which this is the first term, and I plugged a 1 in for n. 5 times 1 is 5. I said I don't want 5, though I want 6. How do I get there? I add 1. And then I just check to make sure that that would produce all my other terms. Now, 66. How do I get from 5? Like, what would I have to plug into n to get up to 66? Or in other words, you could do this. 5n plus 1 equals 66. Minus the 1. 5n equals 65. Divide by 5. And you get n equals, 5 goes into 6 once, 5 goes into 15, 3, 13. So this is going to go up to the 13th number. N equals 1, up to 13 of 5n plus 1. You're done. Okay? All right, so let's see what happens here. Let's look at C. C's a little bit different. C's a little bit different, right? So we're going to do summation notation. This one here, which is n equals 1. Now, let's see what's going on here. We have 1 squared minus 1, 2 squared minus 2, 3 squared minus 3. Okay, this looks like it's n squared minus n, because I'm squaring the 1 and then minusing 1. Squaring the 2, minusing 2, squaring the 3. Okay, and it looks like I'm going to go up to 12. Done. All right, folks, that's sigma notation. Hope that helped, and hope you guys got this stuff. So you can do it. Explicit notations are just a little bit tricky, but not too bad. If it's repetitive addition is multiplication. Okay, so that's what I do. Repetitive addition, multiplication. If it's repetitive multiplication, that is an exponent. Repetitive multiplication is an exponent. So if your sequence has repetitive multiplication, you're going to use that as the base to the exponent of n, or n minus 1. If you are adding every time the exact same amount, you're going to, that's going to, repetitive addition becomes multiplication. Here we had adding 4 every time, that became 4n. Then what I did is I just plugged in the 1 because I wanted to see what I would get out. 4 times 1 gave me out 4, which is what I wanted, so I didn't have to add or subtract anything. Down here, I was adding 5 every time, so that was the 5n. When I plugged in a 1, I got out 5. I don't want 5 though, I want 6. That's why I added 1 to the 5 to get 6, which means I add 1 to my explicit equation up here. Hope that helps. Have a great day. See you later. Bye.